So this chapter is basically not a very tough one, and questions are generally, we talk about NEET, questions are not so difficult from this chapter. If we have basic idea of concept, we can solve the questions easily. JEE also questions are only asked from the limited topics of the chapter, like from resonance, circuit, and quality factor. So if we understand the chapter, questions are generally very when AC comes in our mind, we think that like we can't do the questions kind of mindset we have. Actually, that is not so. If we understand the chapter, it's very easy to score in this chapter. So I would advise you to, be patient. Sometimes we think that this chapter is very difficult. Students have such kind of mindset, but actually the chapter is not so. It seems to be difficult or lengthy, but it is very scoring. You can't miss a question. Generally, questions are very easy or moderate asked from this chapter. If you have some basic idea of the chapter, you can do the questions in each and every so the very first the concept is we know we have the idea of what is alternating current. Anyone? What is alternating current? Anyone can define? How will you define alternating current?
So the value of current is not constant but changes over time and is inconsistent.
Yes, somehow the definition is correct. Like alternating current means current is changing. Alternating, it means it will change periodically. It will not change in a random manner. It will change periodically. Uh, will have some pattern like sine kind of thing, cosine function, sine function. So generally AC currents, alternating currents are periodic in nature. Obviously, it will change with time. So generally, for alternating current, we are writing the equations like this. For an AC, we can write equation like I is equal to omega t, or we can write I is equal to I naught cos omega t, or sometimes we write I sin omega t plus phi. Same like you have seen in SHM or waves, you have seen such type of equations. So, and if you talk about the from the main topic from where we started, basic definition. So the very first thing is RMS value, from where we start conceptual thing from this chapter, IRMS. And we all know that generally we define IRMS is equal to peak value upon root 2. For this function, I is equal to I naught sin omega t or I is equal to I naught cos omega t. We define IRMS is equal to I naught upon peak value upon this we all know. Generally, we also have some general formula to calculate the RMS value. How we calculate that? The R squared dt on, right? So in this formula also we can calculate like this. For any general curve, we can apply this formula IRMS. Basically we go into definition. What is it? RMS is basically root of, okay, we go from reverse side. So it is basically mean of a square and we take root of. So generally we square the quantity, then we'll take mean of that and then we take root. That is how we define RMS. Getting my point? So you go from right side, square the quantity first. RMS means square the quantity, take the mean, then take the root. That is RMS. You see here, we have squared the quantity, we have taken the mean, and here if we take RMS, it will go root to the right side. Actually, the formula is like this. IRMS is. Understood what I am trying to say? So, if you go from back side, RMS means square the quantity like a square, b square, take the mean, like if we have two quantity a1 square plus a2 square by 2. So first square the quantity, then take the mean, then take the root. So how we can do, if there are two quantities, so how we can define RMS value like this, a1 square plus a2 square by 2. Getting my point? Basically this is the RMS. If you have discrete value, if suppose you have two values a1 and a2, so you can find the RMS value of a1 and a2 as a1 square plus a2 square by 2. Getting my point, all of you?
Yes, sir.
So this is basically how RMS is defined. Take the square, take the mean, go from right side, take the square, take the mean, and then take the root. That is RMS. Root mean square. So this is the basic definition of RMS, and if you already, all of you may have seen the derivation how we get. I am not going to derive it. If you do by this formula, if you put value of I in this formula, you will get IRMS as I naught by. So basically, why we required RMS value? The thing is that anyone, why we required the RMS value? If we had the mean value, why did we require RMS value? Why don't we do things by taking mean value? Anyone? What is the requirement of RMS value? Why we need RMS value? What's the reason? So actually what happens when you have an alternating current, like if you have an alternating current I is equal to I naught sine omega t. Actually what will happen if you will take its mean value, it will be 0. If you have any sine or cosine function, like it is sine function, so it is plus and minus. So if you will take mean of that, it will always give you a 0 value. Or if there is a cosine I is equal to I naught cos omega t, the alternating current is like this, I is equal to I naught cos omega t, it will have graph like this. So its mean value will also be 0. So when we were calculating the mean value of alternating currents, we will always get 0 value. So there will not be any use of mean value. We can't do anything by average value or mean value because it is always zero. So that is why we tend to find another way to uh, derive something or to find heat or something kind of thing. So we needed another quantity, and that is how RMS value is defined. RMS value is not zero over a cycle. So that is how RMS value has been created and defined to do calculation is alternating current circuits. Getting my point? So actually mean value was not useful in case of AC. Generally what we do? Generally we do, if there are number of values, we take mean value and do the calculation whatever required. But in case of alternating current, mean value is not so useful. That is why we needed to define RMS. Understood what I'm trying to say?
Yes, sir.
So this is how RMS value comes into play. Now we will do directly do some questions based on RMS value so that we get clarity on that and how questions can be done based on that. So let us directly jump to the questions first. Let us see question number 1. We see. All of you try this question number 1. We have to find the RMS value. The question says a 40 microfarad capacitor is connected to 200 volt 50 hertz AC supply. The RMS value of the current in the circuit is. This is NEET 2020 question. This question will be little difficult for you because you have to know XC also. Either the way we can solve it, but I have little, the next topic is involved in it. We have to calculate capacitive reactance. I think all of you have little idea of capacitive reactance, right? All of
Yes,
you
sir.
know what is XC. XC is 1 by omega. I am giving you a hint how you will calculate IRMS. IRMS is basically will be VRMS upon Z. We can say what is VRMS? 200. What is Z? Z is basically XC here. So 1 by omega. Using this, you can calculate the RMS. Apply it directly. So now we put the value 200 upon what is omega? How you will calculate omega? 2 pi nu. So that is 2 pi into frequency is 50. So 1 by 2 pi into 50 and C is 50 10 to the minus 6. Basically what we will get 200 to 100 pi into 50 into 10 power minus 6. So we will get it as 8 pi to 10 to the power minus 1. So like 8 into 3.14. We will get approximately 8 into 3.14. What is that? 8 into 3.14. That will be 25.12. We will get 2.5. Approximately we will get 2.5. Understood? So this is how you can calculate. Actually, this is not very basic, which we have discussed, but if we have some idea of this one, actually this is NEET 2020, so generally they will not ask I not available two formula, they will give some twist. So we already know that IRMS is VRMS by that. Actually, this topic will be discussed later on, but for the time being, I'm telling you can use directly IRMS is for VRMS by that, and here VRMS is given directly, and Z we can calculate one level. All of you understood this? Any doubt, please ask. I think you have little idea of VRMS upon Z, the formula, right? You all have already done AC in your regular class of 12. Getting my point?
Yes.
Anyone having any doubt? If anyone having doubt, we will also discuss the capacitive reactance and all in the comment sections. So, first, I will do a purely calculation based on question that is RMS calculation. So now you can calculate attempt question number 6. Now if you can attempt question number 6, we have to calculate RMS value from the given graph. So all of you attempt this question number 6. This question you cannot apply it directly, right? I is equal to I naught by root 2. That is only for given sine and cosine constant. Here you have to apply the basic concept of RMS value. So I will give you some hint how to calculate RMS value of that. And all of you try this. You directly have to apply this formula. VRMS square will be equal to, here directly you can apply like this, V square dt divided by this formula you can directly apply. So basically you have to take two time intervals you can directly calculate for two time interval like v1 square dt divided by time t1 0 to t1, and then from t2 to t2 square dt upon t minus t2. So basically you have to calculate v square dt upon dt in two sections. First is 0 to t by 2. So if you put it directly here, like if you see here from 0 to t by 2, the value of v square is v naught, constant, right? So we can write it like this: 0 to t by 2 and v naught square dt upon t by 2. And in second, and the second interval t2 to t, it is 0. So directly we can calculate like this: v naught square into dt will be t by 2 and then t by 2. That is cancel out v naught square. So we got vrms square is equal to v naught square. So we get vrms equal to v naught. Understood? Anyone having doubt, please ask.
No doubts.
Understood it? This is how we can apply the basic formula to calculate RMS value. Moving to the next question. So such type of questions are asked generally in NEET also. This has been asked, and in JEE such questions are asked very few. They will not give you directly, they will give you an equation and will ask to find out RMS. This question anyone can do. So there will be little twist in the question. This question 9 we all of you can solve. RMS is I naught by root 2. Everyone can solve question number 2. Let's see some questions of JEE is based on RMS value. Generally, they don't ask questions directly on RMS value, but sometimes they may ask to calculate RMS value from the given graph. That is so no direct question has been asked from the directly to calculate RMS value. And we'll give you some examples to calculate RMS value. So we have to apply the basic method. That is how we have calculated. Getting my point? Nowadays, generally, no questions are directly asked to calculate RMS value, but sometimes they will give you some graph, or like suppose I will give you an expression. like sometimes you may have given some, for example, these two lines, like you have given variation of current I to 4t. Find RMS value of current. Find RMS value of current over the time, 0 to 4 seconds. Getting my point? We have given a current I is equal to 4t. So find RMS value of current over the time of 0 to 4 seconds. All of you try this. Anyone have got any answer? Are you trying, all of you? We have to apply
Yes, sir.
the same formula, A square dt upon dt, I square dt upon t. So how we will calculate here? We have to apply the same formula. IRMS, that will be calculated like this. IRMS will be equal to,
Sir, 2 root 2.
let us see, I squared dt upon dt. So IRMS square will be that. So it will be 16 t squared dt upon t squared dt upon dt. And we have to take 0 to 4 seconds, right? So 16 will be outside. So that is t squared dt upon 4. So we will get IRMS square. IRMS square will be equal to t. What t squared dt 6 t squared dt upon 4, and here 0 to 2. 4 by 2 is e to the power 3 upon 3. 0 to 4 by 3. 4 minus this 4 into 4 by 3. So what is RMS square? RMS 2 into 8 by root 3. Square point 16 by root 3 ampere. All of you understood? This is how we can calculate. IRMS will be equal to, so you have to apply basic formula 16 by root 3 ampere. So if you don't do any mistake in the integration, you can easily calculate. The main thing is you have to calculate integration, and it is very easy. You can easily calculate. All of you understood?
Yes.
So this is the basic idea of to calculate RMS value. Now the main we have general idea of the RMS value. Now main question starts, or main concept starts when we apply AC to different circuits. So for now we will see AC applied to different circuits. That is the importance starts from here. AC applied to different circuits. So the main concept starts from here, how AC behaves with different circuits. AC applied to different. So first we will see that AC applied to purely resistive circuit. AC applied to purely resistive circuit. Applied to purely resistive circuit. So suppose we have a circuit and which calculates a resistor, and generally we put the symbol for AC like this, and it is applied to the resistor. Now we can take any value. Suppose the AC, you know that AC can be anything like AC alternating current and alternating voltage also. Suppose the applied alternating voltage is V is equal to V naught sine omega. So generally what we will do when we will have any kind of AC circuit, we will first find the expression for current, then we will draw the phasor diagram for current as well as voltage. I will later explain in phasor diagram also. So that will be basic thing which we will do in all the circuit, whether it is applied to capacitor, inductor, resistor, or combination of capacitor, inductors, and capacitors. So in all the cases, the steps will be same. First, we will calculate the current. From that, we can define the phase, the current is leading or lagging, and then we can find the phasor diagram. Getting my point? So all will have same method. Here, if you see from the circuit, what is the current? Current we can write I is equal to V by R. So the current we will get I is equal to V naught sine omega t upon. So here current and voltage are in purely resistive circuit. The current and voltage are in same phase. What is phase? Phase means the sine omega t plus phi term. So if you see in purely resistive circuit, current and voltage are in same. There is no phase change because sine omega t is present in both the expression, voltage as well as current. Actually, this terms, if you see this term define phase. So here, if you see current, we also you can write the current also like this: I is equal to I naught sine omega. Here I naught is equal to V naught by R. So here the sine omega term is same in both the expressions. There is also we have sine omega t term. Here we also have sine omega t. It means both are in same place. Getting my point? All of you can understand this? Anyone
Yes, sir.
having any doubt till now? So this is very basic circuit. Don't need any much effort to understand this. So we draw you all. I think all of you have basic idea of phasor diagram. So do I need to go in much detail?
No, sir.
I think much detailing is not required. So just if I will give you the basic idea. Like if you draw a phasor diagram like this, so generally we will focus on the questions only. So in phasor diagram, generally we show the amplitude. So like if this angle is like omega t, is V naught. So generally what will happen? And current will be also like this here. Current is obviously current is less than voltage. So current phasor will be in same direction as voltage. They all will lie along the same line. Getting my point? So here obviously amplitude of the current I naught will be less than voltage. So we have I is equal to I naught sine omega t, right? And I naught is equal to V naught by R. Obviously I naught will be less than 2. So that is why V naught is shown at the tip of the arrow, and here we are showing I naught since its value is less than V naught. This is the basic idea of phasor diagram, which can be easily understood for in case of pure resistive circuit. Now we will see pure capacitive circuit. This purely capacitive circuit. Actually, phasor diagram is not much needed in numerical. Numerical, we will only need expression. It is only for to write in 11, 12 board exam. Phasor diagram basically not needed to do numericals. So purely capacitive circuit, we will see. We should have some idea, like in purely inductive circuit, purely resistive circuit, current and voltage are in same phase. That is the most important thing, and which will be required when we will do calculation for power and all. So now if we see purely capacitive circuit, so here we will draw a capacitive circuit. Source and AC voltage applied to purely capacitive circuit. So we have DC. Now here what will happen? Here there is some change, like if we calculate current in the circuit, or we will calculate current, V will be equal to V by Z. Basically, we define impedance for capacitive or inductive circuit. So V is equal to V naught sine omega t, and what is Z? Z is equal to 1 by omega c. So now what will happen? Here, if you see, here we are applying purely we are applying the AC to purely capacitive circuit. So here the thing which has changed is impedance, right? Here we have to remember we are not using R or something. Here we are using impedance of a capacitive circuit, that is 1 by omega c. So here if we see, impedance depends upon the frequency. More is the frequency, less will be impedance of capacitive circuit, and larger is the value of frequency, more will be less will be impedance of the circuit. So if you draw the impedance versus frequency graph, you will get it like this. We draw impedance versus frequency graph, you will get a curve like this. Getting my point? If omega increases, or you can say Z is equal to basically 1 by omega c. So when frequency increases, obviously impedance will decrease. So you have to remember that for a capacitive circuit, at omega is equal to 0, basically at omega is equal to 0, or omega is equal to 0 means for DC value, omega 0 means for DC value, it will offer very high resistance. Hence, it will offer very high resistance, or you can also say that at omega is equal to 0, Xc tends to infinity, right? So it will have very high resistance for DC current. It means DC current cannot pass through a capacitor. Getting my point? DC current cannot pass through a capacitor. And for omega is equal to infinity, if you say frequency becomes very high, in that case what will happen? omega tends to infinity. When omega is very high, it means xc will tends to 0. Then we can also say that, or we can also say that the common name known as xc also. U generally we call z or xc. Z or we can say xc. So when frequency increases, capacitive reactance decreases. Getting my point? So the graph is inversely proportional to omega. Now we see the expression of current. What is it? V by Z means V naught sine omega t by 1 by omega. Are you getting my point? So can you say what is the phase difference between current and voltage?
Pi by 2.
What is pi by 2?
90 degree.
No, 90 degrees is okay, but how you can say it is 90 degrees? Or you can say it is 90 degree phase difference. You see here, the current phase is sine omega t, and voltage phase is also sine omega t. Getting my point? So how phase difference is 90 degree? Anyone? So actually what happens here, we make mistake generally. I have written wrong expression for the current intentionally so that you can understand it. In case of current, what we do, we directly write I is equal to V naught by V by R, V naught sine omega t. This is my point. That is for current. But in case of here, all the voltage appears across the resistor. Getting my point? But in case of capacitor, you cannot write all the voltage will all the voltage will drastically appear across the capacitor. Is it so? First it will charge at time t is equal to 0. It will not appear instantly to the capacitor. The voltage will not appear instantly to the capacitor. It will change. Getting my point? So for capacitor, you cannot write V is equal to V naught sine omega t. How you have to calculate voltage? How you will calculate voltage across the capacitor? We know that Q is equal to CV.
Q by C.
V is equal to Q by C. Getting my point? For that, we know that Q is equal to CV. So from here, we will write what is V? V is equal to V naught sine omega t. Now we can calculate current. How we will calculate current? dq by dt. So here generally student makes mistake and they write like this, which is wrong. I wanted to check you how you can identify the thing or not. Generally many students do it like this, and they write V naught by V by Z and they write V naught sine. So actually this is not correct. How you can actually the capacitor is charging and discharging, right? So we have to calculate current by this formula dq by dt, because charge is changing on the capacitor. Getting my point?
Yes, sir.
Generally, what we do, we just remember that I is equal to V by Z, and we apply that. Actually, we have to see there was no charge accumulation or charging discharging thing in the register, but capacitor gets charged and discharged. So you cannot apply Ohm's law on the capacitor directly. You have to calculate current by dq by dt, and then you can write like this: I is equal to d. What is the value of t? Q c v naught sine omega t. Now you can calculate current. How to? We will get I is equal to d by dt of dv naught sine omega t, and from here we can calculate. We will take c outside, so we will get d by dt v naught sine. So from here we can get dv naught d by dt of sine omega t. So I will not derive each and every expression. For the sake of capacitor, I am explaining you. Otherwise, I will directly say that in case of capacitor, current will lead, and in case of inductor, current will lag. Getting my point? So we will not go more detail in the derivations. You already have learned this, so you have to see your notes. So for this, I am doing the derivation. Otherwise, I will directly use the expression of current. I will directly use the result. So from here, what we will get? We will get differentiation of sine omega t. What is that? Minus cos or cos? Differentiation of sine is cos omega t
Cos.
into omega, right?
Yes, sir.
So we will get omega c into v naught cos omega. Now what we can do? We can write like this: I is equal to, basically we can write like this: v naught by 1 by omega c cos omega. Can we write like this?
Yes, sir.
And we will call it xc, v naught by xc cos omega. So what is xc? Xc is 1 by omega c, and we will write like this: I is equal to I naught cos omega. Where what is I naught? I naught is basically peak value of current, and that is v naught by xc. Now we can rewrite it like this: I is equal to I naught sine omega t plus pi by omega t plus pi by. Can we write this? What is sine 90 plus theta? Cos theta. Getting my point?
Yes, sir.
So from here we can see that here current is basically leading. What happens here? Current is leading. We compare it like this: I is equal to sine 30 plus pi. What is y of pi? Pi is pi. So why it is leading? Because of plus sign. So here current is leading. In case of capacitor, current is always leading. Getting my point? C for current, C for capacitor. In case of capacitor, current is leading. So what will happen in case of inductor? Voltage will lead, current will lag. All of you understood? So in case of capacitor, current leads by voltage pi by, by phase pi by 2. If we draw the phasor diagram, what will be that? The phasor diagram will be like this. here current is leading, right? So current is leading means voltage is lagging by 5/2. So we can write it like this. There is no need to draw phasor diagram to this question only. I'm trying for the last time. There is no use of phasor diagram in the questions. So your voltage will lag and current will lead. So that is V naught. So current will be like this. The current will lead by voltage 5/2. Getting my point? So here current will lead by a voltage of by a phase of 5/2 from the voltage. So the basic idea is you can remember like this, or you can also draw the phasor diagram like this also. You can rotate it also, and you can show it like you take like this. It can be also shown like this. You draw the voltage like this, then current will lead like this. So you can also show it like this. All are same. If you take V naught here, suppose this angle is omega t. So you will take at 5/2 angle. Getting my point, all of you? So this is also correct. So main thing is we have to see whether current is leading or lag. So if it is leading, you rotate more angle by 5/2. Here we are rotating by 5/2 plus 2. Understood? So phasor diagram is not much needed in the questions. In question we have to remember phase angle. Getting my point? Should we jump to the question now? Let us do some question based on purely resistive and capacitive circuits. And also let us write one or two more expression. In case of purely inductive circuit, what is the value of current? Purely inductive circuit, because question is generally not asked from one circuit only, from mixture of circuit. So if we see purely inductive circuit, what will happen in purely inductive circuit? If we apply the AC voltage to purely inductive circuit, what will happen? What will be the expression for current? It will become I naught. It should lag. Getting my point? If the voltage is V is equal to V naught sine omega t, what will be current? The expression for current I naught sine omega t minus pi. Their current will lag. Getting my point? We will get current lag. Understood? So here it will lag. And we also have expression for average power. What is average power? Average power is Vrms into Irms into cos. This you have to by heart. This formula will be very useful. What is the value of average power? Vrms, Irms, cos. Where phi is the phase angle. Getting my point? So these formula are generally used for solving questions. Now let us jump to the questions. See this question number 7. Both of you try this question number 7. This is NEET 2008 question. PMT 2008. Very easy question. Both of you try this question. the average power in the circuit over one cycle. If there is a mistake in the question, it is not F, it is basically Y. Are you trying, both of you?
Yes. So option C.
Do you want option? All right. Anyone else? I think your answer is correct. We have to directly apply that formula, right? The average power, and for P average, what we have to write? P average is VRMS, IRMS, cos phi. The phase difference is phi. So VRMS, we know that V naught by root 2 for sine and cosine function. IRMS is I naught by root 2 to cos. So it will be, sorry, E naught. Here in the question it is given as E naught. You can write E naught by root 2. So we will get E naught by naught 2. Understood? Very easy. So actually, in a very easy question will be asked in the NEET and JEE based on AC. Till now, no hardly difficult question has been. The chapters seem to be difficult, but if you know basic concept of that, you can solve. Now see this question number 8. Again, you can easily solve. Try question number 8. Any answer?
So option A.
what option A. Anyone else? Why option A?
Sir, because in an AC circuit, the phase differences also plays a key role, right? So power is directly proportional to the phase difference.
Yes, you are correct. Since we know that P power, actually power is VRMS, IRMS cos phi. If they are saying power, it means generally we will take average power. So obviously, if we don't know phase difference, how we can calculate power? Suppose the phase difference in 90, the power will be 0. Getting my points. So it will all depend upon the phase angle. If we don't know phase difference, we can't calculate the power. Getting my point? Is the correct answer. All right. Let us jump directly to the LCR circuit and LR circuits. Then we will do the question that is questions. They are based on purely inductive or capacity. Then we will jump to the so this question number 1 is in Jamin. Question very easy. Why you were absent in the last class, Krishna? Try to attend the class regularly. If you miss something in between, it's very difficult. You want to try, you want to climb what we say, something by stairs, like you have to use every step of the stair, getting a point. The thing is, same thing is here. Every class and every step is important. If you miss steps in between, there can be difficulties. So try to be regular in the class, all of you. Are you trying this, Krishna?
Yes, sir.
Sir, option D.
What option D? D or B?
D.
Have you calculated B? The question says that, let us see first the question. Why you were absent in last class, Namuna? You had exam or something?
Yes, sir.
Try to be regular in the class. So the question says an alternating voltage is applied. There is only one class in the week, right? An alternating voltage is applied to a purely resistive load of 50 ohm. So the alternating voltage is given like this. The voltage is given from 220 sin something, so it will be sinusoidal voltage over the line. And purely resistance is given as 50 ohm. The time taken for the current to rise from half of the peak value to the peak value, we have to find. So suppose this is like 0, we know that this interval is time controlled. 0 to, this is 0 to t by 2 and this is t. We know that the total time for complete cycle is t, so this should be t by 2. Getting my point?
Yes.
Now time taken from O to A will be how much it will be t by 4. Understood?
Yes, sir.
So in the question it says that the time taken for the current to rise from half what is applied to the time taken for the current to rise from half of the peak value to the peak value. We want to find that half of the peak value to the peak value. So we know that time taken to reach the peak value is t by 4. So time for peak is t by 4. It means 1 by 4. And what is t? T is 2 pi by omega. So it will be 1 by 4 into 2 pi upon omega. So what is omega? Omega is 100 sin omega t. So omega is 100. So we'll get it as pi by 200. Is the time taken to reach the peak value. Now we have to find the time taken for the current to rise from half of the peak value to the peak value. So suppose peak value is V naught. So we have to find the time taken to rise from V0 by 2 to V. We have to find that time. So generally, we cannot write it Tp by 2, right? That will be wrong. Getting my point? Tp by 2 cannot be the answer. So what is the value of Tp basically? Tp is basically pi means 3.14 divided by 200. So what will be its value? Its value will be 3.14 divided by 200 means 0.015. 0.0157 means 15 millisecond is the time taken required to for peak value, right? Obviously should be less than 15 minutes. It should be around something 7 to 6 kind of thing. Getting my point? So we will check that actually. Now to calculate the time taken for the current to rise from half of the peak value to the peak value. How we will calculate that? Any idea? I don't know how you calculate it.
So we
Basically,
should
we have
take for T by 2.
what we have to do is we have to put in that in the formula. We cannot take T by 2. Getting my point? So the formula is V is equal to V naught sin omega t, and it is given at sin 100 t, right? The question what is it is given at 220 sin 100 t. 220 sin 100 t. 220 sin 100 t. T is given as 220 sin 100 t. So if V is equal to V naught by 2, we can calculate that time. Getting my point? This is V naught sin omega sin 100 t t1. So we can calculate time taken to go from 0 to V naught by 2. Getting my point? So we can calculate t1 here. What will be t1? We see here 1 by 2 is equal to sin 100 t1. So from here we can calculate, see that sin 100 t1 is equal to 1 by 2, and that we can write sin pi by 6, and pi by 6 is 1 by 2. So from here we can calculate t1 is equal to pi by 600. Getting my point? Can we calculate t1? Both of you understood this one?
So I didn't get this part, sir, from the half
Actually,
value.
see, the expression for voltage is this. Now I am calculating the time to rise voltage from 0 to V by 2. So for that I put the value of V equal to V naught by 2. Understood?
Yes, sir.
Suppose in time t1 voltage rises to V naught by 2. So from here can we calculate t1?
Yes, sir.
Now if we calculate t1, now we have to calculate time taken from t1 to tp. Getting my point? We have to find time from T1 to TP. So how we will calculate? We will subtract T1 from TP. Getting my point?
Yes, sir.
We will subtract because from here to here, the time taken is T1, and from here to here, time taken is TP. So in this between, how we will calculate? We will subtract TP minus T1. Understood? So
Yes, sir.
required time we will get by delta T, that is required time, we will get TP minus T1. What is T1? TP is pi by 200 for peak value, and for half value it is pi by 600. So from half to peak we will calculate it as 600, and this will be 3 pi minus pi. So we will get pi by 3 pi minus pi 2 pi by 300, right? We'll get the time as pi by 300 second, and pi by 300 will be equal to approximately how much it is? We divide 3.14 divided by 300, we will get approximately 0.0104. It means approximately how much we will get? 10.4 millisecond. Getting my point? 10.4 millisecond something. It should be in the option. 10.4 milliseconds. Calculate 3.1. I think there is something. I think there is some, this term A is given. Is it millisecond? Something maybe printing mistake. You see here, this A is also given. What is it?
I
Maybe
think that
some.
is angstrom.
Maybe that is pi. I think. Is it pi? Not will be angstrom because it can be pi. Let us put it pi. Let me check by putting it pi. It can be 100 pi t also. So from that we will get. Let me try by taking it pi. So if we put it 100 pi, so pi will be cancel out. Getting my point? So we will get 1 by 200 and 1 by 600. Understood? Pi will be cancel out. So we will get T1 as pi by 1 by 600. Got it? And TP we will got 1 by 200 because pi will be cancel out. So we'll get it delta Ts. Get delta Ts 1 by 200 minus 1 by 600. We'll get 600 and 3 minus 1. So 2 by 600 means 1 by 300. So 1 by 300 means calculate it 1 divided by 300. 0.003 second. It means 3 into 10 to minus 3 second. It means 3 millisecond. Is there in the option? Approximately this will be correct. Getting my point? 3.33 something will be. Understood?
So how I mean half time is equal to 1 by 600?
Let us see. We actually in the question there was mistake. It was actually 100 pi t. Getting my point? So
Yes, sir.
if you put it like this, here if you put 100 pi, So how much pi and pi will be cancel out from here? Getting my point? You will get 100 pi is equal to sine 100 pi t1, you will get sine pi by 6. So from here what you will get t1? T1 you will get 1 by 600. Understood? Pi and pi will be cancelled out.
Yes, sir.
Understood? Similarly, TP you will get 1 by 200. All calculation will remain same, only pi will be removed because pi was there, pi will be cancelled out. Do you try yourself also? Do it